or you can go to menti.com and put in this code. And then once you're in, could you just click the like button just so that I can see, so I know people are in? So either follow the link that I just posted in the Teams chat or menti.com, and I'm getting a bit of feedback on my voice, and put in this code. Oh, has somebody got their mic on who doesn't intend? Obviously, you could put your mic on if you want to say something, but okay, it looks like we've got one person. Anybody else? Once you're in, just click the like button. Okay, we've got a few people coming in. Okay, great. So I'm gonna assume. Well, I'm gonna go ahead because obviously those of you that are here on time, I don't want to waste your time. So the question is going to be on the slide. We're just going to do one question at the beginning today because we've got a lot of content I want to get through. So I'm going to give you 2 minutes to do this question. Off you go. Got a minute and a half left. As usual, don't worry if you can't do it. I'm going to go through everything. Okay, 1 minute left. Thirty seconds. Okay, last 10 seconds. Okay, so we've got 3 people said E, 1 person said B. The correct answer was E. So well done, those of you who got that right. So just quickly then, so we want the share price yesterday for Drebs. For share price 1 month ago. And today's price is 40% more than the price 1 month ago. So 18 is 140% of what it was before. In other words, the original price, the price a month ago times 1.4 would equal 18. So we need to do 18 divided by 1.4, and that gives us 1286 when we round it. So that's E. If you didn't follow the logic there, don't worry. This is one of the skills that we're going to go through. Okay, so picking up where we left off last time, we're going to try and finish fractions today and hopefully get through as much of percentages as possible. So apologies if you weren't here previously. I'm not going to recap anything, but it's all there in the notes and question packs and things which you have access to. So find a given fraction of a given amount. So for example, what is 3/7 of what is 3/7 of 1261? What is 12/5 of 72? So to do this is very straightforward. We just multiply the fraction by the amount. Now, if you want to, you can use your fraction button, or you can simply just type in the fraction as a division and then multiply it by the total amount to find what that, so in this case, to find what is 3/7 of 1261. And your calculator, because division and multiplication are equal priority, the calculator will just work left to right. And so we get the answer 540.4 roughly in this case. And then again for the other one, so 12 over 5 times 72. Whoops, it's done it all in one thing. So 12 over 5 times 72. And we get 172.8. And notice that is bigger than the starting value. That's because our fraction is a top-heavy fraction. So we're essentially timesing it by a value that's more than 1. In fact, it's about 2.4. Okay, so calculate what fraction a given amount is of another amount. Sounds a bit wordy, but it's actually quite straightforward. So, for example, what fraction of 567 is 49? Now, the difficult thing with this really is the wording. It might be a bit confusing, but the thing to focus on is the word of. Which number has the word of in front of it? That's going to be the thing that's at the bottom of the fraction, the denominator. So what we're looking for is a 49 as a fraction of 567. So in other words, 49 is the top of the fraction and 567 is the bottom of the fraction. And when you put that into the calculator will simplify it for you, and we get 7 over 81. So the same thing again, what fraction of 81 is 153? So don't be misled by the fact that 81 is the smaller number. That doesn't matter. Fractions can be top heavy. The point is we're looking for it as a fraction of 81. So it's 153 over 81, which is 17/9, 17 over 9. And this one's worded slightly differently, but again, we're just going to look for that word of. That's going to be our denominator, the bottom number. What is 156 as a fraction of 276? And we get 13 over 23. Okay, so given an amount and what fraction it is of another amount, calculate the other amount. So this is kind of similar, but this time we know what the fraction is, and we know what the amount is that fraction of the main amount, but we don't know what the original amount is. It's easy with an example. So 34.8 is 5/7 of another number. Yeah, okay, we've got some slides on this. So what is that number? So we're looking for a number that 5/7 of it is 34.8. So it's going to be a bit more than 34.8. It's going to be like 40 or 50 kind of region. Okay, so let's think about this. 5/7 times this, we're going to call it x, this unknown value that we're looking for. 5/7 times that number equals 34.8, because remember, this is how we find a fraction of an amount. We just multiply the fraction by the amount. So 5/7 of x is 34.8. Therefore, if we rearrange this equation, we get x. So we divide both sides by 5/7, then we get x equals 34.8 divided by 5/7. Okay, so we could do that on our calculator. 34.8. It's not actually going to be that easy to do on this online calculator, but you could do it on your calculator quite easily. Is it going to let me divide? No. Okay, it won't really let me do it, but you can imagine, you can do it on your calculator. Another way to do it is to divide 34.8 by 5 and then times the answer by 7. So let's do that on here. 34.8 divided by 5 equals that. And then we do answer times 7. And we get 48.72, which is the correct answer. So why does this second method work? Well, remember, 30.8 is 5/7 of x, 5/7 of this unknown number. So if we divide it by 5, which is the first step here, that will give us 1/7. Okay, so we divide by this top number of the fraction. That gets us down to 1 of whatever it is, so 1/7 in this case. If we then times that by 7, times it by the bottom number, that's going to give us 7/7. In other words, the whole thing, the whole lot of it. So that gets us the answer. So those methods both work. Now, in terms of typing this into the calculator, we could just do that in one step. So we could just do 34.8 divided by 5 times 7, and we get the answer. So that might be a bit quicker than using ands like we've got on the screen here. And also similarly with this one here, so we could do this as 34.8, 34.8 divided by brackets 5/7, close brackets. That would get us the right answer. But also, if you know about division, you know that what we're really doing here is you could expand this into divided by 5 times 7. So it ends up being the same as this way anyway. Okay, so 9/5 of a number is 540. What is that number? So we could do 540 divided by, and then use our fraction button to enter 9/5. We could do 540 divided by brackets 9/5, 9 divided by 5, close brackets. Or we could do 540 divided by 9 times 5. And all of those are really the same underlying maths anyway. They're just different ways of thinking about it, and they all give you the same answer. So divided by 9, that gives you 1/5, times it by 5, and we get 300. Okay, cool. So increase or decrease a given amount by a given fraction of itself. Okay, so the number 2000 is increased by 3/8 of itself. This gives, oh sorry, what number does this give? Okay, so there's more than one way to do this. In the notes, I've only put in one way, so I'll show you that. So the most obvious way to do it is to find 3/8 of 2000 and then add that onto 2000. So we already know how to find a given fraction of a given amount. 3/8 times 2000, that's 750. And then we just do plus 2000. Your calculator will probably put ands here, so do ands plus 2000. And we get 2750. If you're good with doing fractions in your head, I'll just mention this quickly. You might notice that what we're really looking for is 11/8 of 2000, because 2000 is 8/8 of itself, it's 1 of itself, and we're adding on 3/8. So we could actually do 11/8 of 2000, and we get the same answer. So if you're confident with fractions, if you can do that kind of thing in your head easily, then go for it. If you think you're not 100% confident, just do it in 2 steps. Find 3/8 and then add it onto the original. The number 57 is decreased by 7/12 of itself. What number does this give? Okay, so first we find, let's clear this, 7/12 of 57, 33.25. Okay, and then what we want to do is take that away from 57, because it's a decrease this time. So we do 57 minus ands, and we get 23.75, which is correct. Now again, if you're confident with fractions, you might notice that what we're really looking for is 5/12 of 57. And we get the same answer. Okay, so given the fraction of itself that the initial amount was increased or decreased by, and the final amount, calculate the initial amount. Again, sounds complicated, but isn't really. So a number was increased by 3/4 of itself to give 105. What was the original number? Okay, so what we want to do is we want to think about what fraction of itself, what fraction of the original number is the final number, the one that we've been told. So the original number is the one we're looking for. The final number is the one we've been told. So in this case, it was increased by 3/4 of itself. So that means it's going to be 1 3/4 of itself. Okay, now if you're confident with fractions, you might just know that that's 7/4. It's 7/4 of itself because 1 is 4/4 plus 3/4 is 7/4 of itself. If you're not, you can just think of it as 1 3/4. So, and you can just put that into the calculator as 1 plus 3/4. Division will be done before addition, so you don't need brackets. And the calculator will do that. And on your calculator, it will probably come up with 7/4 rather than putting it as a decimal. But you could also use it as a decimal. It doesn't really matter. Okay, so all we have to do... Oh, I've actually got some nice little pictures for this. Okay, so let's use these. So the original number is this amount. It was increased by 3/4 of itself. So 1 3/4 of x, this is x here, and this is 1 3/4 of x, is 105. So if we divide by 1 3/4, we will get the original number. Or we can think of it as 7/4 of x is 105. So 105 divided by 7/4 will give us the original number. Okay, so we could just do 105 divided by 7/4. If you want to use the mixed number 1 3/4, use that instead. I already in last week showed you how to enter mixed numbers into the calculator. Anyway, you get the answer, which is 60. And you might notice here that we could have done 105 divided by 7 times 4. That also would have been fine. Okay, so then, yeah, there we go. Okay, so a number was decreased by 2/5 of itself to give 28.2. What was the original number? So the original number, since we're working with fifths here, let's say the original number is 5/5 of itself. In other words, it was 1 of itself. If you decrease it by 2/5 of itself, what we now have is 3/5 of the original number. So you may well be able to do that in your head. If you can't, then just come over to your calculator. We want 1 of the original number minus, in fact, we don't actually need brackets, but I've started putting them in now. 2/5, and your calculator will probably say 3/5, or it might say 0.6. It doesn't really matter. We can use either. So we want to divide 28.2 by 3/5, and there's different ways to do that. So let's say 28.2 divided by 3 times 5, and we get 47. Now you could also use the decimal 0.6, so 28.2 divided by 0.6, and we get 47. So there's different ways to do it. Okay, so that brings us to the end of fractions, which is good. We're making good time. So let's move on to percentages. Sorry, I can't open the document. But I just go through it on here anyway. So convert between percentages and decimals. This is the first one. Oh, and if anybody wasn't here before, let me just share this in the Teams chat. This is the web page where I have put all of the syllabus and question packs. So if you go on syllabus, you can find percentages here, and we've got question packs for it as well. Okay. So convert between percentages and decimals. So what is 64% as a decimal? What is 0.793 as a percentage? What is 0.6% as a decimal? So just really quickly, I'm sure you're even if you haven't done maths in a while, you've probably encountered percentages in your life. They come up all the time. So percentage is basically how many parts out of 100 something is. And if you think about the word percent, cent means 100 in like Latin or whatever. And per is kind of like, miles per hour, meters per second, miles to the gallon or whatever. So miles per gallon. So it's like per 100. How much out of 100 is it? So 64%. It's like 64% out of 100. And we can actually also think of per. That per word is meaning like divided by. So 64%. Also, we could think of it as 64 divided by 100. Because it's kind of 64 over 100 as a fraction. And remember, fractions and divisions are equivalent to each other. So that actually tells us how to convert a percentage to a decimal. We just divide it by 100. So 64% is just 64 divided by 100. See if you can do it in your head before I get that. Yeah. 0.64. So a lot of these percentages, it's quite obvious what the decimal is going to be. Like if it's 35%, it's just 0.35. If it's 12%, it's just 1.2. But you've got to watch out because you might have something like 35.01% and you want to convert that to a decimal. You can easily get tripped up in your head or miss out the zero or put the decimal point in the wrong place. So, to be safe, you've always got the option of just putting it into the calculator just to check. And in that case, it would be 0.3501. So to convert a decimal to a percentage, we just do the opposite. So we just times by 100, the inverse, I should say. So 0.793 as a percentage is 79.3. And again, you may not need to use your calculator. It might be quite obvious to you, but just watch out because you can trip yourself up on these, and you can always use a calculator to check if you're not sure. And then the last one, 0.6% as a decimal. So 0.6 divided by 100, and we get 0.006. So the way that I find it helpful to think of these is like, obviously the number 1 as a decimal is 100%. The number 0.1 is 10%, and the number 0.01 is 1%. So 0.6 is a bit less than 1%, so it's a bit less than 0.01. Anyway, okay, convert between, isn't 12% 0.12? Yes, what did I say?
You said 1.2.
Oh, I'm really sorry. Thank you. It's a good thing that we have Tina here to catch my mistakes. Yes, thank you, Tina. It's definitely 0.12. Yeah, 1.2 would obviously be 120%. And remember, of course, percentages can be more than 100. And so if you have, 120% of something, that would be more than the original amount. Okay. Convert between percentages and fractions. So this is super easy to do because we've already learned how to convert percentage and decimals. That's what we did just now. And we already know how to convert decimals and fractions using calculator because calculator does it for you. You just need to press that little SD button that switches between decimal and fraction. Okay, so all you do is convert it to a decimal and let the calculator do it for you. Now let's see if my online calculator can do this. So 36.8% as a fraction. So let's divide it by 100. That will convert it to a decimal. But the calculator is not showing it as a fraction. Let me do it on my real life calculator. You won't be able to see this. And we get 184 over 5. I don't know if this one can do it. 36. Hopefully you've all got calculators with you and you're actually following along with this anyway. Oh yeah, this one can do it. 46. What's going on here? Why have I got two different answers? Oh, I didn't divide it by 100 in my real life calculator. Yeah, so it's 46 over 125. And you probably all did that more competently than me. Anyway, so 3/14 as a percentage. So we just put in 3/14. Now that's going to give it as a decimal if we just type it in. Whoops. If we just type it in, it's going to give it as a decimal. We then times that by 100, that decimal will be converted to a percentage, and we get it there. So it'd be 28.43% roughly.
George,
Yes.
I have a question. I was just wondering, let's say you didn't have a calculator.
Yeah.
Does the numerator have to be a whole number? Like, can you not put 36.8 over 100? It has to be a whole number.
Good question. That is a perfectly valid fraction. So you could put 36.8 over 100, how it's been displayed on here. That is, you can even have something like pi over 100. So it doesn't even have to be a rational number. But obviously, if you're asked for a fraction in its simplest form, then that would be whole number, like the smallest whole numbers possible. Does that answer your question?
Yes, thank you.
Okay, cool. So, did we do this one? No. So 0.2%. This is the kind of one where you might get tripped up because you might think, you might have a little leap in your brain. No, I'm not accusing you of doing this. It's the kind of thing I would do. And you might think, oh, 0.2, so that's 20%. But it's 0.2%, so it's like a fifth of 1%. Okay, so if we just use our method, in order to make it, we first have to make it a decimal, so we have to divide by 100. This is a very small number. And then the calculator can convert that to a fraction, and it's 1 over 500. Okay, so find a given percentage of a given amount. So what is 14% of this number here, 5 million, etc.? Okay, so it's kind of the same as finding a given fraction of an amount. We just multiply the percentage by the amount. So to find 14% of this number, we just multiply 14% by this number. However, we obviously don't have a percent. Well, you might have a percentage button, but most calculators don't have a percentage button. If they did have one, all it would be doing is dividing the number by 100. So we don't have a percentage button, so we have to either convert this to a decimal or a fraction in order to do that. And as I say, you may be able to do that in your head. I said that before and then immediately did it wrong. So that shows you the pitfalls. But you may be able to just go, okay, that's 0.14, and then times that by 5,764,655, and then you get the answer, which is 807,051.7. If you're not confident or you don't want to trust your mental maths, obviously you can just do 14 over 100. That converts the percentage to a decimal or a fraction, and times it by, I say decimal or fraction because it will just depend on what your calculator displays. It doesn't matter basically. We're just finding that value so that we can multiply it by this other value. And times it by that. And again, as I said many times, division and multiplication equal priority. The calculator will work left to right, so we don't need brackets. And we get the same answer. Okay, so the next one, find 135% of 62. So obviously 135% is more than 100%, so the number is going to get bigger. The final amount is going to be more than 62. It's always good to do little, just to think about things like that before you press equals on your calculator or before you type it into the calculator, because we all mistype things in the calculator. We all make silly mistakes. And one of the best ways to avoid silly mistakes is to do a sense check. So, and not just to do a sense check, but to actually just think in your head like, okay, this is going to be about, it's going to be more than 62. It's going to be less than 90. It's going to be somewhere in that range, right? So if you get an answer that's not what you're expecting, then either your thinking was wrong or what you put into the calculator is wrong, and it gives you a chance to spot errors. Okay, so 135% is 1.35. And when we do that, times that by 62, we get 83.7. Again, if you don't want to do the conversion in your head, just do 135 divided by 100 times 62, and you get 83.7. Okay, and then the last one, 75% of 900. So we could do 0.75 times 900, and we get 675. Or we could do 75 over 100 times 900. And we get 675. Or you might just spot the fact that 75% is 3/4. Okay, so you could actually do 3/4 of 900. There's certain percentages that you would probably know what fraction they are, right? 50% is 100, 20% is a fifth, 60% is 3/5, 25% is a quarter, 90% is 9/10, and so on. So if the fraction version is obvious to you, you could use that. So in this case, we could do 3/4 times 900, which is actually a little bit quicker to type in, and we get the same answer. Or we could even do 900 divided by 4 to find 1/4 times 3. One situation, imagine if the question, I put this at the bottom of this section of the notes. Imagine if the question was asking you to find 25% of 900. This is where you could save a bit of time in a question like that, because you would go, oh, 25% is a quarter. But finding a quarter of something, what you're doing is you're dividing it by 4, right? Because if we have if you go back to your kind of primary school fractions and we have a quarter of the pizza, then that's, a fourth. It's 1 part in 4. In other words, we're just dividing the pizza in 4. So if it was 25% of 900, then we could just do 900 divided by 4, which is quicker than typing in 900 times 0.25, for example. Now, obviously, when I'm saying things like this, it's not going to save you masses and masses of time. If this was an A-level maths class or a GCSE maths class, I wouldn't be pointing out these things. It's only because it's numerical reasoning test, which is time-based, it's very time-pressured. I'm pointing out little areas that you could type things into the calculator a bit quicker. But at the end of the day, if doing that takes you out of your comfort zone and then you make a mistake, it's not going to be worth it. So, if you're comfortable with these kind of things, then you can use them. But if you're not, if you haven't done maths in a while and you just want a reliable method, just use the standard method that's the same for every time. So it's 75 over 100 times 900 will get you the answer. Or if it was 25%, then 25 over 100 times 900. Okay, so calculate what percentage a given amount is of another amount. So this is basically what we did with fractions, but now we're doing it with percentages. So what percentage of 64 is 48? So again, it's that of tells us this is the kind of the bottom of our fraction, if you like. I know we're looking for a percentage, but just to momentarily think of it as a fraction, this is the bottom, the denominator. So what percentage of 64 is 48? In other words, you could think of it like, if the total is 64, what percent of that is 48? Or if 100% is 64, then what percent is 48? So we already know how to find what fraction it is, because we did that earlier. and we already know how to convert fractions to percentages. So we can just combine those two skills. And this whole kind of the way that I've structured this course is that you're learning skills that you'll then combine this skill, and that allows you to do it. That unlocks this thing, and then you combine that with this, and that unlocks this thing, and then suddenly you can do really hard numerical reasoning test questions. Because it's just all just individual skills that can be mastered as long as you go in the right order. So 48 over 64. Now your calculator would probably pop up with a fraction, 3/4. It doesn't really matter if it shows a fraction or a decimal. We just times it by 100 and we get it as a percentage, so 75%. Now, when you calculate a percentage, you have to remember to write down the percent symbol, because it's not going to show percent on the calculator. Doesn't know that you're calculating a percentage. It just thinks you're doing 48 over 64 times 100. What is 35 as a percentage of 20? So this one is going to be more than 100%. We can spot that straight away because 35 is more than 20 and it's a percentage of 20. So 35 over 20. And we can actually just do the times 100. Oh, this is what we did last time. Sorry. Yeah. So we can do it all in one go. 35 over 20 times 100. And it's 175%. I think in the notes I put 2 different ways of doing this, but we'll stick to this. But have a look in the notes if you want more of a discussion about different ways to do this. So what percentage of 500 is 2? So 2 over 500. Whoops. Times 100 to make it into a percentage. And we get 0.4. Okay, so it's 0.4%. Oh yeah, this is where you could again make that classic error. That is definitely the kind of thing I might do if I wasn't paying attention. And see 0.4 and think, oh, we're calculating a percentage. It's 40%, but it's not. It's 0.4%. We've already times it by 100. We've already done the conversion. Okay, so given an amount and what percentage it is of another amount, calculate the other amount. So this is just like what we did with fractions, but using percentages. So 66 is 48% of another amount. Sorry, 66 is 44% of another amount. What is the other amount? So this is the total amount. I should have put the question on here so we could see it at the same time. But 66 is 44% of the total amount. So this is the total amount, is the big rectangle. And this part of it here, 66, makes up 44% of the total. And we'll call the total x. Okay, so in other words, x times 44% is 66. Or x times 0.44 is 66. So if we divide both sides by 44%, we get x equals 66 divided by 44%, or 66 divided by 0.44, and we just type that into the calculator. There are other ways to do this type of question. For example, you could say, okay, 44% is 66. So if we divide 66 by 44, we get 1%. And if we times that by 100, we get 100%. But I would say this is the easiest way to do it. Okay, oh, and let's do the other 2 questions. So 35% of an amount is 196. What is that amount? So 196 divided by 0.35, so is it divided by 35%, and we get 560. Or if you prefer to do the, if you don't want to do the conversion in your head, 196 divided by, this time we actually have to use brackets for once. because otherwise it will go left to right, and we want to do this division first to convert the percentage to a decimal, and then we want to divide by that decimal, and then we get 560. Example 3, 102,600 is 160% of another amount. What is the other amount? So again, just a little quick thing to notice, this is 160% of the other amount. So this is more than the other amount. So the other amount is going to be about 2/3 of this. Something like 60,000, 70,000, maybe something roughly in that region. So 102,600 divided by 160% is 1.6, and we get 64,125, or we can divide it by brackets, 160 divided by 100, and we get the same answer. Okay, calculate percentage increase or decrease. So this is a real classic topic that is going to come up in numerical reasoning tests. Percentage increase, percentage decrease. You want to just get really, really accurate and quick at doing these, which is why there'll be loads of practice questions in the question pack that I have put online today. Okay, sorry for the weird highlighting here. So the population of the UK in 2001 was 59,113,000. In 2011, it was 63,162,000. What was the percentage increase in UK population over this time? Okay, so the way we want to think of this, all of these type of questions, we have an initial value, a final value, and then the amount of increase or decrease. Okay, and we're looking for what was the increase or decrease as a percentage of the original amount. Okay, that's what percentage increase or decrease means. It'll be clearer when we go through the example. So we've got the initial value, and let's say we're doing an increase. Okay, so the final value is more than the initial value. How much more? This much more. This is the amount of increase. Okay, so we want to find out what is the increase as a percentage of the initial amount. So say, for example, the price of a PlayStation 3 was £100 and it went up to £110. That means it increased by £10. What is £10 as a percentage of the original price, which was £100? It's 10%. So going back to our population question, the original population was this amount here, 59 million and etc. And the final value, final population was 63,182,000. So the increase, we've already learned right back at the beginning of the course, we did how to find the difference between two numbers. If you've forgotten that, go and have a look back at those notes for a refresher. But essentially, we just want to do 63,182,000 minus 59,113,000, and that tells us the difference, which is 4,069,000. So we want to work out what is that as a percentage of the initial value. We've already learned how to find what percentage a value is of another value. So what we can do is just divide this amount by 59,113,000, and that gives us it as a decimal, and then times it by 100. Obviously we could have done that all in one step, and we get 6.88%. So that's the answer. So it's an increase of 6.88%. Now, I did actually think today that you could actually speed this up a bit. Again, this is just for people who are interested. If you just want a standard method that will work every time, just go with what I just said. But just for anyone who's interested, Well, firstly, we don't really need the 0, 0, 0 on the end because we're just doing percentage. We just want to know what it is as a percentage. So we could actually just save time by not putting the 0, 0, 0 into the calculator because it's all going to be scaled up and down. The proportions are going to stay the same. But secondly, we could actually just divide this amount by this amount and times that by 100. That will tell us what percentage this is of this, which will be 100 and something percent. And that something will be the percentage increase. So if we combine both of those tricks, again, if this is losing you, don't worry. Just use the method that I just went through. But just for people who might want a time-saving trick. Now, if you just look at the calculator, you might be happy to just do the conversion in your head. So this is as a decimal. This is 106.88%. So in other words, the final value is 106.88% of the original value. Therefore, how much did it go up by? Well, it went up by 6.88%. So if you're confident doing that kind of thing and thinking about all of that in your head, you could save a lot of time with this kind of thing. Now, this only works for percentage increase. If you try to do something like this for percentage decrease, there would be more steps to it. But I'll let you think about that if you want to. So percentage decrease, again, we work out the size of the decrease. What is that as a percentage of the initial value? So let's have a look at question 2. A company's profits in 2019 were this much. In 2020, they were this much. I'm sure you can all guess what happened. What was the percentage decrease in profit between these 2 years? So applying that onto our little diagram, that was the initial amount, that was the final amount. The decrease, we just work out the difference. So just this minus this, and you'll get this amount. And then we work out what percentage is that of the initial amount. So 33,301. Now, always there's an easy mistake to make here also will be dividing it by the wrong amount. So make sure you always divide by the initial amount. So always just double check, take your time to make sure you're dividing by the initial amount. Doesn't matter if it's an increase or a decrease, we always divide it by the initial amount. And then let's times by 100 to make that into a percentage. And we get 13.56% was the size of the decrease there. And then the third one, just do real quick. A school had 876 pupils last academic year. It has 854 this academic year. What is the percentage change? Is this an increase or decrease? Well, first of all, it's obviously a decrease. You can just see that from the numbers. It's gone down. But I just put that in just to highlight that sometimes we might just use the general term percentage change, which is just like an umbrella term for percentage increase and percentage decrease. So calculate the difference. Minus 854 is 22. What is 22 as a percentage of the original amount, the initial value, times by 100 to convert to percent, and we get 2.5. Oh, I think I've done something wrong. I think I typed it into the calculator wrong. So 876 minus 854. No, that's right. Oh, 860. Oh, I've copied the question down differently between the notes in here. That's why I've swapped the 7 and the 6. But you get the point. And obviously, if you wanted to use, well, actually, yeah, I'm not showing you how to do that because there's a bit more to it. Okay, so given the initial value and the percentage increase or decrease, calculate the final value. Okay, so I'm just trying to think. We started about 3 minutes late, so we've got 5 more minutes. So we'll see how much we can get through. There's only 2 more bits of percentages, including this one. So between the years 2000 and 2015, the price of a Freddo chocolate bar rose by 150%. This is actually true. I looked it up. If the price of a Freddo in 2000 was 10p, what was the price in 2015? Okay, so do I have a little diagram here? No. But I can draw one. So the original price, whoops. This one where I've written loads in the notes. Okay, so the original. Oh no, sorry, that's the next skill. This one's a bit easier. So we know that it rose by 150%. We know the initial amount. So first of all, we're just going to find out what is 150% of the initial amount. So it's just 1.5 times 10p, which is 15p. Or you could do 150 over 100 times 10. And then we just add that on to the initial amount. So we just, in other words, convert the percentage increase to an actual increase, and then add that increase onto the initial amount, and you get the final amount, which is 25p. The second method, the second way of thinking about it is that if this is the initial amount was 100% of itself. And then we added on 150% of itself. Yeah, because the percentage increase was 150%. So it increased by 150% of the initial amount. That means that the final amount is 250% of the initial amount. Because 100% plus another 150% is 250%. So therefore, we could just take the initial amount and times it by 250%, which is 2.5, 250 over 100, and we get the answer more directly. So if you're happy thinking about that kind of thing, you can save yourself some calculator time. The number of visitors to an aquarium was 117,824 in 2019. If there was a 75% decrease in visitors between 2019 and 2020, how many visitors were there in 2020? So again, we just work out what is this decrease as an actual amount of the initial, and then we just, in this case, take it away from the initial amount because it's a decrease. Okay, so we want to find 75% of this amount, and I showed you earlier lots of different ways that you could find 75%. You could divide it by 3 and times it by 4, for example. We'll just use this method. And we get 88,368. So then we want to do initial amount take away the decrease, so minus ands. And then we get the answer, which is 29,456. Now, if you wanted to do it in one step, you would just have to realize that the new amount is 25% of the initial amount because it went down by 75%. That just leaves 25%. So in this case, we could just do 0.25 times 117,824, and we get the same answer. And we could even just divide 117,824 by 4, because that's the same thing as finding 25%, because 25% is a quarter. Okay, and then lastly, the global atmospheric CO2 concentration in January 2011 was 391 parts per million. By January 2021, this had increased by 6.14%. What was the global atmospheric CO2 concentration in parts per million, January 2021? So really quickly, this will be the last thing we do. Let's find 6.14% of the original values. So 0.0614, that's our conversion to decimal, times 391 equals that. That's the amount of increase. Then we add that on to the initial amount, 391, and we get 415.000074. If we want to use the other method, which is definitely quicker and doesn't require you to type in as many numbers that you might make a mistake on, we would just realize that the final amount is 106.14% of the initial amount, because it was 100% of itself, and then it increased by 6.14% of itself. So that is 0.10614. That's 106.14% as a decimal, times the initial amount, and we get the same answer. If that was too quick for you or it didn't quite make sense, have a look in the notes or just ask on the Slack channel anytime, and we'll get back to you. But I think Horatio has left. Let me just check. Horatio, are you there? No. So he did say to me, if he's not here, to just end the meeting for him. So yeah, does anybody have any questions or comments before we finish? No? Okay. Well, thank you all for coming, and I will see you next week. Bye.
Thank you.
Bye. Thank you.
You're welcome.
Bye.
Thank you. Bye.